So here in this question, we have a function given by sine x degree over x, and we have to find its limiting value when x tends to 0. Now here x is measured in radians, whereas the angle of sine, which is x, is given in degrees. So that means we need to convert x degrees into radian. So we have to convert x degrees to radians. How do we do that? So we will use the fact that 180 degree is equivalent to pi radians. So that would mean 1 degree will be equals to pi over 180. So x degrees will be equals to pi times x over 180. So this is going to be a radian value. Now we are going to substitute the value of x degree into a given limit. So that will be, we have limit x going to 0. So we have sine. So instead of x degree, we are going to use pi x over 180 divided by x. However, we know that we need pi over 180. Pi over 180 times x in the denominator. So we're going to multiply the denominator by the denominator x by pi over 180. Now this is an extra term, so we have to divide. We can say we are going to multiply the entire function by pi over 180. So that gives us finally this limiting value. So this entire value is going to be 1 because it's using the definition that limit theta going to 0 sine theta over theta is going to be equals to 1. So now that we have it, so this entire limiting value is going to be 1 and we are left with pi over 180. So this is going to be the limiting value of sine x degree over x when x tends to 0. So here we have the function sine x degree over x degree. This time the denominator is also in degrees, whereas the limiting value is given as x, which is in radians. So x is going to 0. So that means we need to convert x degrees to radian. So like in the previous question, so we have x degrees is equals to pi x over 180. So let us replace it there. So this is going to be equals to limit x tending to 0. So we have sine x degree. So x degree will be pi x over 180 divided by x degree, which will be simply pi x over 180. So this is all in radian. Now this limiting value is going to be simply equals to 1 because this is using the definition that sine of some angle theta divided by theta at x tends to 0 will give us a limiting value of 1. So we have the function given by x squared over sine x squared when we need to determine its limiting value when x tends to 0. Clearly this particular limit is using the definition that when limit tends to 0, theta over sine theta is going to give us 1. So here theta is actually represented by x squared. So that means the limiting value of this given function when x tends to 0 is simply going to be equals to 1. So here we have the function given by 10 squared 3x over x squared, and we need to determine its limiting value when x tends to 0. So let us rewrite our given function. So we have limit x going to 0. So we have 10 squared 3x, which is similar to, or we can rewrite it as 10 3x whole squared divided by, so we need a 3x squared here. So we're going to divide by 3x whole squared and multiply by 3x whole squared. And we have x squared in the denominator. Now this was done so that we can use the definition that tangent of 3x over 3x squared. So this limiting value is going to be equals to 1. Or let me instead break it down. So we have limit x going to 0, then 3x over 3x, and we have 3x squared over x squared. So here we are going to use the definition that limit theta goes to 0, tan theta over theta is going to be equals to 1. So we have here 1 times 1. So 3x squared over x squared is going to give us 3. So the limiting value of the given function, tan squared 3x over x squared, is going to be equals to 3 when x tends to 0. So here we have the function sine 3 theta over tan 2 theta. We need to find its limiting value when theta tends to 0. So we can rewrite our given function as limit theta going to 0. So we have sine 3 theta over 3 theta. So 3 theta being an extra term, so we have to multiply by 3 theta. Whole thing divided by tan 2 theta. So we're going to divide tan 2 theta by 2 theta and multiply it by 2 theta. So this takes care of the extra 2 theta here. Now we're going to apply the limit to the numerator. That will be sine 3 theta over 3 theta divided by, we're also going to apply the limit to our denominator. So we have limit theta going to 0, tan 2 theta over 2 theta, and we are left with 3 theta over 2 theta. So the theta and theta gets cancelled out, and that is going to leave us with 3 over 2. So we have finally equals to 3 over 2. So the limiting value of the numerator is going to be 1. So is the limiting value of the denominator, and the final value is going to be 3 over 2. So we have to determine the limiting value of the function given by sine squared 4 theta squared divided by theta raised to the power of 4. So let us rewrite the given function. So we have limit theta going to 0. So sine squared 4 theta squared can be rewritten as sine of 4 theta squared whole squared. Now what we're going to do is, okay, that's fine, divided by theta raised to the power of 4, which is equals to limit theta going to 0. We have sine 4 theta square. So we're going to divide it by 4 theta square times and multiply it by 4 theta square. We have whole squared times 1 over theta raised to the power of 4. So this will be equals to limit theta going to 0. We have sine of 4 theta squared over 4 theta squared whole squared times 4 theta squared whole squared, so that will be 16 theta raised to the power of 4 divided by theta raised to the power of 4. So the theta raised to the power of 4 is common to both the numerator and the denominator. That gets cancelled out, leaving us with 16. And the limiting value of this particular function, sine 4 theta squared over 4 theta squared whole squared, is going to be 1. So the limiting value of a given function when theta tends to 0 is going to be equals to 16. So here we have a function given by 3 sine x minus 4 sine cube x over x. So we have to find its limiting value when x tends to 0. So without using trigonometry, also this problem can be solved. So let's do that. So we separate the two terms in the numerator. So we have limit x going to 0, 3 sine x over x minus 4 sine cube x over x. Now we're going to apply the limits separately to each of the two terms. So we have 3 times the limit x going to 0, sine x over x minus 4 limit x going to 0. So we have sine cube x. So sine cube x will mean there are 3 sine x here. So that means we need sine x over x. So that means we need 3x's here. So we need an x cubed in the denominator. So that means we need to multiply by x cubed and divide by x. So the first limit will be simply 3 times 1 minus 4. So this limiting value is going to be 1 and this is going to be x squared. So we are left with limit x going to 0 x squared. So this value is going to be 0. So that means we have 3 minus 4 times 0, which is giving us a limiting value of 3. However, if we are to use trigonometric identity, so we know that sine of 3 theta, which can be obtained by expanding sine of theta plus 2 theta, that will give us 3 sine theta minus 4 sine cube of theta. So that means our given function can be rewritten as limit x going to 0. So we have sine 3x over x. So what we're going to do, so we need a 3x in the denominator, so we're going to multiply by 3 in the denominator and multiply a 3 to the numerator, so that takes care of the 3. Now the limiting value of sine 3x over 3x when x tends to 0 is going to be 1, and that leaves us with a limiting value of 3. So either way we can find the answer. So here we have the function 7x cos x minus 3 sin x divided by 4x plus tan x. So we have to find the limiting value when x tends to 0. So what we're going to do, we're going to divide the numerator and the denominator by x. So that will give us 7x cos x minus 3 sin x divided by x. And we're also going to divide the denominator, which is 4x plus 10x divided by x. Now we divide each term in the numerator, which is 7x cos x and 3 sin x, by x. So we have 7x cos x over x was going to give us 7 cosine of x minus 3 times sin x over x divided by, so we have 4x over x, which is going to give us 4 plus 10x over x. Now we're going to apply the limit to each of the terms in both the numerator and the denominator. So we have 7, which is a constant. So we have 7 multiplied to limit x tending to 0 cosine of x minus 3 being a constant, we write in front of the limit. We have limit x tending to 0 sine of x over x divided by, so limit of x tends to 0 of 4 is simply going to be 4 plus the limit of x going to 0, we have tangent of x over x. So that gives us 7, so limit of cosine of x and x tends to 0 is 1, so we have 7 minus 3, so limit of sine x over x is going to be 1 divided by 4 plus the limit of tangent of x over x when x tends to 0 is going to be simply 1. So that gives us 4 over 5. So this is going to be the limiting value of the given function when x tends to 0.